So this is the second video, and we're going to pick up right where we left off on our notes here. Now, let's just recap. We graphed, ladies and gentlemen, the most important parabola of all, the parent graph, y equals x squared. That's the easiest one to do. And we graphed it using an xy table. We plugged in 0, we squared it, we got out of 0. Plugged in a 1, squared it, got out of 1. Squared 2, got out of 4. 3 squared is 9. And if you do the negatives, you get those outputs. We have this parabola. And also, on the last time we did this lesson, we concluded that the a value tells us how wide the parabola is. If the a value is closer to 0, it's going to get wider. Like if you had a 1/2 right here, it'd be wider. If you had 1/10, it would be really wide. It'd still be opening up. If it's negative, if it were just a -1, it would be exactly this wide, but it would be opening down. You guys remember that? Okay, so the a value tells you how wide your parabola is and whether it's opening up or down. Now, today we're going to learn a certain shortcut. If your a value is 1, it's going to be exactly this width. It's not going to be wider, it's not going to be narrower. Even if it's -1, it's going to be exactly this width. Now, what does that mean? That means that I could use a pattern from the vertex and use that pattern whenever I have the a value of 1 or -1. 1, 1, 2, 4, 3, 9. It's on the bottom center part of our notes. So if we're at the vertex, if you go 1 over, 1 up, that's how you get to this point. If you go 2 over, 4 up, that's how you get to this point. I mean, on this parent graph, these are actual coordinates, 1, 1, 2, 4, 3, 9. But we're going to use that pattern of 1, 1, 2, 4, 3, 9 to graph any parabola that has a value of 1 or -1. And again, that pattern comes from these coordinates right here on the parent graph. They're actual coordinates, coordinate 1, 1, 2, 4, 3, 9, but we're going to use it as a pattern, not as coordinates. So, bless you. What else did we learn? We learned that the most important point is a vertex. It's either the highest point or the lowest point, depending on if it opens up or down. And you could tell by looking at the a value if it opens up or down. And also, through that most important point called the vertex, there's a dotted line that we draw that we call the axis of symmetry that provides a reflection on both sides. So let's go down to this graph down here. Now, I need to find my most important point, which is called the vertex. Everybody on the right side of this thing, let's write down vertex. And we know that the vertex is a coordinate, an x and a y value. And how do I find this vertex?
The x and y are plugged in.
Negative b over 2a. That's right. The formula, x equals -b over 2a. And we're going to do negative parenthesis over 2 times parenthesis. Now, where the heck am I going to get the b and the a value from our original equation? Now,
Is a
what's the a value?
x.
1. What's the b value?
0.
0. What's the c value?
3.
-3, even though we're not using the c value. Still important to understand. Now, if some people are like, wait a minute, isn't the b value -3? No, the b value is always with x. So if you're confused right here, you might as well write it out like this. Y equals 1x squared for the a. There is no x, so you're going to put a 0 for the b, 0x, and the -3 is a c. That way, here's a, here's b, and here's c. All right, so let's plug in our b value, which is 0, over 2 times the a value, which is 1. That's going to give us -0 divided by 2. -0 is still 0, and 0 divided by any number is still 0. So what did I just find here? I found x equals 0. The x of the vertex equals 0. I still need the y. How do I find the y?
Plug it in.
I plug it in into the original. So I want to take the x value of 0, plug it right into the x. Why? Because x equals 0. So 0 squared is 0, and 0 minus 3 is -3. Maybe I'll show my work here so nobody gets confused. Y equals x squared minus 3. I'm going to plug in 0 for x. So it's going to say 0 squared minus 3. 0 squared is still 0. 0 minus 3 is -3. So the y value is -3. So the vertex, the most important point, is the coordinate 0, -3. Everybody please graph 0 on the x, -1, 2, 3 on the y. Put that vertex right there. Now, what is the very next thing to do once you find that vertex? If you totally forget, that's why we have these notes up here. Step 1, find the vertex. by using negative b over 2a, then plugging in x to solve for y. Step 2, draw your axis of symmetry.
Wait, don't you do the 1, 1, 2, 4, and 3?
Well, even before that, I would draw our axis of symmetry. So up here it says steps, second step after your vertex, draw your axis of symmetry. You draw that vertical line that goes right through that vertex. So even though it's clear that the vertical line here is the y-axis, but let's still draw it anyway. And let's also label it. That's going to be the axis of symmetry. Now that's going to provide us a reflection from one side of this axis of symmetry to the other. I just need more points. If I wanted to, I could go to an XY table to find more points. That's what you normally would do. If you want more coordinates, you go to an XY table. And I could plug in some points that are pretty close to the axis of symmetry the vertex x value. So for example, if I wanted to, I could plug in the number 2 or 3, right? If I wanted to plug in, let's just do it for funsies here, plug in the number 3, what's 3 squared? And what's 9 minus 3? 6. So 3, 6 really is a coordinate on this graph. But instead of wasting time and doing that simple math, why not recognize that the a value is 1, which means if the a value is 1, the a tells you the width of your parabola. So if our a value is 1 and this original parent graph a value is 1, that means they're going to be exactly the same width. Does that make sense? The graph that we're doing right now, the a value is 1. The first parent graph that we did, the a value is 1. It's going to have this perfect exact width. It's not going to be wider. It's not going to be narrower. It's going to be in a different location. The vertex is a different place. It's not at 0, 0, but it's going to be exactly the same width, which means we could use a pattern 1, 1, 2, 4, 3, 9. So let's go down here and let's go to that vertex and let's use the pattern. It even says it down here in the middle, guys. You could use a pattern with the parabola a value of 1 and the pattern's 1, 1, 2, 4, 3, 9. Now let's learn how to use that pattern. From the vertex, you're going to go 1 over, 1 up, and you're going to put a dot right there. Then you're going to go back to the vertex, and then you're going to do the 2, 4 part. So from the vertex, 2 over, 4 up. Okay, now why am I going up instead of down? Because the a is positive, right? If it would have been negative, I'd be going 1 over, 1 down. If it were negative, I'd be going 2 over, 4 down. But it's positive, so I'm going 1 over, 1 up. I'm going 2 over, 4 up, right there. And I'm going 3 over and 9 up. So I have that half of my parabola. All I have to do is map those coordinates over to the other side, right here, and right there. Super easy to do. How did I do that? All I do is count how far it is away from that reflection line, from the axis of symmetry. It's 1 unit away, go 1 unit, plot your point. 2 units away, 2 units, plot your point. 3 units away, 3 units, plot your point. We have our perfect parabola, guys, without doing any math besides finding the vertex, right? Like I could have plugged in numbers for x's, pulled out answers for y's, and it'd give me all these coordinates. I plugged in 3, I got out a 6. Where's that at? Let's go over here. 3, 6. Hey, I found that point anyway, right? But I found it without doing any math by using the pattern. We could use a pattern of 1, 1, 2, 4, 3, 9 when your a value is 1 or negative 1. Because if it's negative 1, the only difference is that parabola is going to open down instead of up. But it's going to have the same exact pattern, 1, 1, 2, 4, 3, 9. Make sense? So let's flip this paper over. And there's several questions that have the a value of 1. Let's graph those. Check this out. Number 1, the a value is 1. Okay? What's the very first thing you should do to graph your parabola?
X equals negative b over 2a.
Yep, and I actually like to write out the word vertex and put down a coordinate and remind me that it's an x and a y value. And of course, to find that vertex, it's going to be x equals negative b over 2a. And when you use the formula, use parentheses instead of the b and the a, and then plug in your b and a right in there. So what is the b value?
Negative 2.
The b is negative 2. What's the a value?
1.
1. Okay, the a value is 1. So the b value is negative 2.
Positive 2.
The a value is 1. So up on top, a negative 2 that changes to positive 2. So I really have a positive 2 up on top over 2 times 1, which is a positive 2 on the bottom. So what does x equal? x equals 1. We just found the x value of the vertex. This answer belongs right in there. That's the x value of the vertex. Once you have the x value, you still need to find the y. How do you do that? Plug it in. So you have y equals x squared minus 2 times x minus 1. And what are we plugging in for x? 1, because we found that x equals 1 with the formula. So a 1 right there and a 1 right there. You could use a calculator if you want, but we don't really need it here. 1 squared is 1. 2 times 1 is 2 with the minus sign in front of it, and with the minus 1 at the very end. So if you go 1, take away 2, take away 1, you're going to end up with a negative 2 as your output, right, as your y value, negative 2. Let's graph that most important point, 1, negative 2. That is right here, ladies and gentlemen. That's the first step on graphing. What's the second step on graphing? Draw your axis of symmetry. After your vertex, draw that vertical line, that dotted vertical line right through it, called the axis of symmetry. You could abbreviate if you want. Now we need more points. How could you find more points? With the XY table. But is it absolutely necessary to plug in numbers for X and pull out answers for Y?
No.
Not on this one. Why not?
Because you have the 1, 1, 2, 4, 3.
Because you have that pattern 1, 1, 2, 4, 3, 9 that you could use only because your A value is 1. Right? The A value is 1. It's going to be exactly as wide as the original parent graph with the pattern 1, 1, 2, 4, 3, 9. So check it out. From the vertex, we're going to go 1 over 1 up or down? Up, because A value is positive. So 1 over 1 up, and you put a dot right there. And if you're thinking, well, do I go 1 over this way or do I go this way? Any way you want, because you're going to map it over anyway. And then go back to the vertex 2, 4. 2 over 1, 2, 3, 4 up. And finally, last but not least, go back to the vertex. Go 3 over 1, 2, 3, 9 up. 2, 4, 6, 7, 8, 9. I'm way off the graph, but it's okay. I want to graph it anyway. So there's half of our parabola. Let's map it over to the other side. Get a point here, get a point there, and get a point way up there. But we're not even going to graph all the way up there. Let's just draw our parabola pointing towards those. And that's it. We graphed it without doing any math right here on the XY table. Any questions? It's pretty easy. So, could we use the pattern 1, 1, 2, 4, 3, 9 on this one? No. The A value is 2. Now, maybe tomorrow I'll show you how to manipulate the pattern 1, 1, 2, 4, 3, 9 to be able to use it on number 3. But we could use the pattern 1, 1, 2, 4, 3, 9 right here and right there. You know what? Maybe we could use the A pattern 1, 1, 2, 4, 3, 9 right there also. How about you guys try these easy ones that have the A value of 1, and then before we leave, I could show you the pattern, the manipulation of the pattern when you have a different A value. Go for it. Try it. Try this one. I might as well finish off this video by showing you how to apply the pattern when your A value is not 1, all right? So, number 2, if you find your vertex by doing x equals negative b over 2 times a, and you know that your b value is 0, your a value is negative 1, your b value is 0, your c value is 3. So you'd have 0 divided by 2 times negative 1. That'd be negative 0 divided by negative 2, which is still 0. So your vertex x value is 0. And to find the y value, you simply plug it in. So you're going to have y equals negative x squared plus 3. And all you're doing is plugging in a 0 right there. So you get 0 squared, still 0. Negative 0, still 0. And 0 plus 3 is 3. So your y value is 3. Your vertex is 0, 3. There's our vertex. That's the most important point. The very second step to do when graphing a parabola is to draw your axis of symmetry right through it. And you could label it axis of sym. Okay? And now we need more points. We could use the XY table if we wanted to, but because the A value is negative 1, we could use a pattern 1 over, 1 down, and put a dot right there. And we could go back to the vertex and go 2 over 4 down and put a dot right there. And go back to the vertex and go 3 over 9 down. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm off the graph, but that's okay. I'll draw it off the graph. And then we map them over to the other side. Again, 1 unit away, map it over, 1 unit away. 2 units away, map it over, 2 units away. And you have your perfect parabola right there. Just point it towards those that are off the graph. So it's really easy to use the pattern 1, 1, 2, 4, 3, 9 when the a value is 1 or negative 1. Now, let me kind of prepare you for this next one. The pattern 1, 1, 2, 4, 3, 9 came from the coordinates of the parent graph, right? So if your a value is something different than 1, you can't use the pattern 1, 1, 2, 4, 3, 9, but you could modify the pattern based on the a value, modifying the outputs. So if your a value is 2, all you have to do is modify your output. This was your input, this is your output. You'd have to modify that by multiplying it by 2, and multiplying it by 2, and multiplying it by 2. So the new pattern for your a value being 2 is to multiply your outputs by 2. So it would be 1, 2. It would be 2, 8. It would be 3, 18. So again, inputs 1, outputs 2. Inputs 2, outputs 8. Inputs 3, outputs 18. So we modified our pattern. Instead of 1, 1, 2, 4, 3, 9, it's 1, 2, 2, 8, 3, 18. Same thing, if your a value would have been 3, it wouldn't be 1, 1, it would be 1, 3. Instead of 2, 4, it'd be 2, 12. If your a value was 3. Make sense? If your a value was 1 half, then it would be 1, instead of 1, 1, it would be 1, 1 half. Instead of 2, 4, it'd be 2, half of 4 is 2, so 2, 2. Make sense? So your a value, whatever it is, if it's different, you could use the pattern 1, 1, 2, 4, 3, 9, but you have to modify every single one of those second numbers on the pattern. Every single one of those outputs, you have to modify it according to your a value. If your a value is 2, you have to modify all of them by multiplying the outputs by 2. Or you don't have to deal with the pattern. You could just go with the XY table. It's totally up to you. So on number 3, let's find the vertex. Everybody write down vertex. Let's write down how to find that vertex. X equals negative b over 2 times a. And let's plug it in. Negative parenthesis over 2 times parenthesis. The b value is negative 8. The a value is 2. So we're going to have a positive 8 divided by 4, which means that the vertex x value is 2. A divided by 4 is 2. To find the output, to find the y value when your x value is 2, all you got to do is plug it in. So I want to rewrite it as 2x squared minus 8 times x plus 5, and I am plugging in the x value of 2 right in there. And when I do the math, 2 squared is 4, and 2 times 4 is 8. And then minus 8 times 2, that's 16, plus 5. I want to have a negative 8 plus 5. Negative 8 plus 5 is negative 3. The vertex is 2 on the x, negative 3 on the y. The next thing to do would be to draw my axis of symmetry right through it. And of course, I need more coordinates. So you could use an XY table and plug in some easy numbers, or you could modify your pattern. I want to go with plugging in numbers. Plug in 0. That's really easy to do. When you plug in 0, you're going to get the c value as your output because everything else turns to 0. So 0 is the input, 5 is the output. If you were to graph that, you get this point up here, 0, 5, it's right on the edge. Which other number would be good to plug in? If you plugged in 0, you might as well plug in the number 1, so you could get a coordinate somewhere right here, so you could get half of the parabola and then map it over to the other side. So when you plug in 1 for x, that's going to be a 1 squared, that's 1. 1 times 2 is 2. And then 1 times negative 8 is negative 8. So you have 2 minus 8 plus 5. 2 minus 8 is negative 6. Negative 6 plus 5 is negative 1. So when you plug in a 1, you get an output of negative 1, and you get that coordinate right there. Ladies and gentlemen, we could just map over those blue dots to the other side, and you'll have those coordinates, and you do have that perfect parabola already. And yes, it's a little more narrow because the a value is further away from 0. It's 2. That's how you graph it. I could have modified my pattern by multiplying. As a matter of fact, we did modify the pattern. Over here is the modified pattern, 1, 2, 2, 8, 3, 18. So from the vertex, let's just verify that the pattern 1, 2 works. So if we go over here to the vertex, 1 over, 2 up, it does get you to that next point. If you go back to the vertex and go over 2 and up 8, 2, 1, 2, 3, 4, 5, 6, 7, 8, it really does give you those coordinates anyway. So I've showed you both ways, using the XY table or actually modifying your original pattern of 1, 1, 2, 4, 3, 9 by modifying those outputs by the new a value of 2. So on number 4, let's do this one together right here. Let's find the vertex. What's the vertex? Or how do I find the vertex? X equals what? Negative b over 2a. What's the b value? The b value is 1. So let's put a 1 right here. The a value happens to be what? In this case, 1/2. Okay? So when I do the math, on top I'll get a negative 1, and down here 2 times 1/2 is 1, which means that my x value is negative 1. My vertex x value is negative 1. In order to find my y value, I need to plug it into the original quadratic trinomial equation. So I have a y equals 1/2 times x squared plus x minus 3, and we're plugging in a negative 1 right in there. And when I do the exponents, negative 1 squared, in parentheses, that really is positive 1, and then 1 times 1/2 is 1/2, and then plus negative 1 minus 3, that will give us a final answer. You can do it on a calculator if you want, of negative 3.5 or negative 3.5, whatever you want to call it. So the y value is negative 3 and 1/2. And where is that? Negative 1 on the x and negative 3.5 on the y. That's negative 1, 2, 3.5. It would be right here in between, right there. And then you make an axis of symmetry. Wait, I usually do that in green, sorry. Now you could modify the pattern 1, 1, 2, 4, 3, 9, 1, 1, 2, 4, 3, 9. You could modify it by multiplying by 1/2, multiplying by your new a value of 1/2. So instead of 1, 1, you'd get 1, 1/2, 1, 1/2. Instead of 2, 4, you'd get 2, 2, because 4 times half is 2. Instead of 3, 9, you're going to get 3 and then 4.5, 4.5. So you could use that pattern from that vertex. A lot of people don't like dealing with the pattern if the a value is not 1, so you could just jump straight into the XY table and plug in some numbers. An easy number to plug in would be 0. If you plug in 0, you get out a negative 3. 0, negative 3 is right here. Map it to the other side, you get right there. So far we have this kind of parabola. And then it would be another good idea to plug in like 1 or maybe even 2. Let's plug in 2. Why do I decide to plug in 2? Because I know that 2 squared is 4, and it's easy to take half of 4. So I'm plugging in 2. 2 squared is 4. Half of 4 is 2. 2 plus 2 is 4. And 4 take away 3 is 1. So when I plug in a 2, I get out a 1. And if I go to the coordinate 2 on the x, 1 on the y, it's right there. And all I do is map it over to the other side, which it's 1, 2, 3 units away. 1, 2, 3 units away. And that's my coordinate right there. So there's my parabola. Just connect the dots. It is definitely wider than your regular parent graph because the a value is closer to 0. That's why it's wider. So I've done a lot of examples on this video. I need you guys to try these guys on the right side. That's your homework for tonight.